Is a shopping mall on the moon or trendy Martian colonies still part of science fiction? Or are we approaching this reality? As NASA aims to send humans back to the moon as early as 2025, the hope is to pave the way for future settlements on the moon. Mark Symes explains the research behind getting oxygen to sustain human life on the moon or on Mars.
You can either take all that oxygen with you from Earth in very heavy tanks, or the alternative is we develop methods for producing oxygen from resources that we find on the surface of the moon. So there is ice at the polar caps on the moon. So conceivably, astronauts could mine some of this ice, melt it, and then decompose the water into hydrogen and oxygen. But no one had really ever considered the effects of reduced gravity on electrolysis. And specifically, we were interested in studying what the gravitational fields on the moon or Mars would do to electrolysis.
Right. So what did you find?
So what we found was that the efficiency of the process is lower than on Earth. So it could be maybe up to 10% less efficient to do this in terms of how much energy you have to put in compared to how much oxygen you get out. But it appears that the electrolysis of water could work on the moon.
Awesome. How did you conduct these experiments where you changed the gravity that was affecting your experiments?
Yeah, so this is the really difficult and perhaps really the interesting part. So a team of students from the University of Glasgow and also from the University of Manchester took a jet that does free fall parabolas. So this jet climbs high into the sky and then it dives down towards the ground. And as it is at the top of this arc, you get moments of weightlessness inside the plane for about 20 seconds, where the experimenters and the experiments all are at 0G, essentially. And then they use the centrifuge to apply, say, lunar or Martian gravity. And these flights are really quite arduous, you could say. They're part of astronaut training. Some of the astronauts call it the vomit comet because they really can make you feel quite nauseous. So it's no mean feat to not only undertake the flight campaign, but also to collect useful experimental data as you do so.
Wow, so you sent a bunch of researchers onto this jet and they also collect data while they were trying not to vomit.
That's right. So these are PhD research students. So they're young, fit, and healthy, and able to undertake this. And I was quite happy to be sat behind my desk in my office at 1G, not undertaking any of these parabolas.
Wonderful. How costly are these parabolic flight experiments?
So these parabolic flight experiments are expensive and they impose a lot of particular conditions on the type of experiment that you can do. And in fact, one of the findings from our research is that maybe some development of experiments for low gravity, so for the moon or for Mars, could be conducted just in Earth in a regular laboratory, not in a parabolic flight, using a centrifuge spinning round, producing gravity slightly higher than Earth, and then extrapolate the results down to gravity levels below 1G, which are obviously much harder to access.
Great. What is the next step for these kind of experiments, and how then does this impact future lunar or Mars colonies, for example?
Okay, so the future prospects for this work are a myriad. So certainly there's some work that needs to be done in cell design, so making these things robust so that you could fly them to the surface of the moon, improving their efficiency further. The other thing that we're interested in is getting oxygen directly from the moon rock. So instead of electrolyzing water to get oxygen, we could maybe take moon rock, which is just a whole bunch of metal oxides, and then at high temperature electrolyze that to directly get oxygen. And that research will also build on these parabolic flight experiments because, of course, again, we'd be doing that electrolysis at low gravity. And there's a lot of different avenues we could take for this research going forward.
Being able to create oxygen from lunar resources means we are one step closer to living on the moon. That was Evelina Wang speaking to Mark Symes from the University of Glasgow about their work published in Nature Communications this week.